30 synthetic login records are scattered across a lab folder. One account fails 6 times, succeeds once, and then accesses an administrative page. Reading every file takes minutes. A small Python program finds the sequence in seconds, explains why it matters, and writes a report without touching a live system. By the end, you will have 5 beginner-friendly project ideas and a complete local demonstration of the strongest starting project. The goal is not another port scanner with no explanation. It is a portfolio that proves you can collect evidence, make a careful decision, handle errors, and verify your result. Project 1 is a log triage tool. Give it a directory containing synthetic JSON records. It validates required fields, normalizes timestamps, sorts events, and groups failed sign-ins by user inside a short time window. If failures cross a threshold, it creates a finding. A later success raises the priority, but does not claim compromise. Your report should show the evidence, rule, uncertainty, and next analyst check. This project teaches files, dictionaries, dates, functions, command line arguments, and tests while looking like real blue team work. Our lab is completely local. The host is lab WS01, the user is analyst lab, and the address comes from documentation space. The generator writes ordinary success and failure records to a temporary project folder. There are no passwords, tokens, production logs, live targets, network calls, or attack traffic. That boundary makes the demonstration repeatable and safe. The script begins with an allow list of event types and 6 required fields. Each file is decoded as JSON. Missing fields, invalid timestamps, unknown outcomes, and oversized files are rejected with a clear message. Valid records are copied into normalized dictionaries while the original file remains unchanged. Early validation prevents malformed data from silently changing the result. Next, sort records by time and group failed logins by user and host. A sliding 10-minute window counts failures. 5 or more produces a medium finding. A success from the same source shortly afterward raises it to high for review. The rule is intentionally simple, visible, and testable. Beginners should be able to explain every line before adding anomaly models. A finding means investigate. It does not mean the account was compromised. The first version raises a finding after the 5th failure and another after the 6th. That looks dramatic, but describes one burst twice. A unit test catches the duplicate. The correction creates a stable key from user, host, rule, and window start, then keeps one finding with the full event count. Run the test again. 1 burst, 1 finding, 6 supporting events. This mistake and fix sequence is valuable portfolio evidence because it shows reasoning, not just code. Project 2 is a file integrity monitor. Walk 1 explicitly approved folder with pathlib, calculate SHA 256 digests, and save a baseline. A later run reports added, changed, and removed files. Exclude secrets, symbolic links, huge files, and the baseline itself. Do not quarantine or delete anything. Add tests for an unchanged file, a modified file, and a file outside the approved root. Project 3 is a configuration auditor. Use a synthetic JSON file representing settings such as firewall enabled, automatic updates enabled, and minimum log retention. Compare those values with a versioned policy. Return pass, fail, or unknown and explain the evidence. Keeping assessment separate from remediation teaches an important security habit: detect and review before changing state. Project 4 is a phishing-header triage simulator. Feed it synthetic email headers, not a live inbox. Compare the from, reply to, return path, and authentication result domains. Flag display name mismatch, failed authentication, and unexpected reply domains. Never fetch a link or open an attachment. The output should explain each signal and remind the analyst that headers can be incomplete or forwarded legitimately. Project 5 normalizes sample vulnerability exports. Create fictional JSON and CSV reports from 2 imaginary scanners. Map both into one schema with asset, identifier, severity, evidence, remediation, and source. Deduplicate carefully and preserve provenance. This teaches CSV, JSON, data modeling, and reporting without scanning any target. Add asset importance and exposure as context, but never pretend one score decides business risk. For each project, publish a clear README with the problem, safety boundary, architecture diagram, setup, sample input, expected output, tests, limitations, and improvement ideas. Include a screenshot of the result and one failure you fixed. Do not commit real logs, secrets, credentials, customer data, or copied code. A small project you can defend in an interview is stronger than a large tool you cannot explain. Start with the log triage project. On Saturday, generate 20 synthetic events, validate them, and implement one failed login rule. On Sunday, add the duplicate alert test, write the README, and record a short demonstration. Then extend one dimension at a time, more event types, better time windows, structured output, or a tiny local dashboard. The best beginner automation is the one you can explain, test, and improve. Find the full project blueprint and safe sample design at CipherVibe.com.